Okay, let me start. Good morning, ladies and gentlemen. On behalf of CII and on my personal behalf, I'm privileged to extend a warm welcome to all participants who have joined this second edition of Future Mobility Show and Summit. As many of you would know, the first edition of Future Mobility Show was held in Bangalore in February 2019. It was a resounding success which had attracted over 12,000 visitors, 75 exhibitors, large business delegates from Japan, China, Thailand, and UK, and a very well-attended international conference on future mobility, which deliberated upon topics such as responsible mobility, energy security, environment, urban mobility, and Make in India. This year, Future Mobility Show 2020-21 is being jointly organized by Confederation of Indian Industry, Society of Indian Automobile Manufacturers, SIAM, and Automotive Component Manufacturers Association, India, ECMA, on a digital platform as you all participating now. The 7-day exhibition and 2-day conference is supported by the Ministry of Commerce and Industry, Department of Commerce, Ministry of Housing and Urban Affairs, Ministry of Power, Ministry of Road Transport and Highways, and Ministry of Environment, Forest and Climate Change. I thank all the ministries, the policymaking body, for joining us today. FMS 2021 will showcase latest products and innovation of zero emission standards, including vehicles for future mobility, alternate energy solutions, and related infrastructure. We have also tried to encourage participation of Indian startups. We are joined by delegates from across the globe who are working on future mobility solutions. Just a few words as context setting. India is one of the most important partners of COP of the United Nations Framework Convention on Climate Change, UNCCC. India's commitment towards the climate and nationally declared contribution has also earned many accolades from the international communities. India is keen to resolve the issue of deteriorating air quality. As per some estimates, vehicle pollution adds to around 40% of the air pollution in India, especially in cities. Curbing it would not only contribute immensely to improve air quality, but also prevent deteriorating the environment. Recent technological development in battery and advanced cell chemistry are producing high power density batteries and at much lower cost. This will eventually make the electric cars travel longer distance in a single charge, making them more affordable. With Atmanirbhar Bharat, India is also laying a huge focus on manufacturing. Automobile is one of the champion sectors, and very soon we expect not only manufacture our components for future mobility to fulfill domestic demands, but will also be able to become globally competitive. As it has been the focus of all stakeholders over the past few years, the central government particularly has come up with many initiatives to promote clean mobility in India. Faster adoption and manufacture of hybrid and electric vehicles was brought in by the National Automotive Board of Department of Heavy Industry in 2015, followed by FAME 2 in 2019. The National Hydrogen Energy Mission by the Ministry of New and Renewable Energy, inclusion of hydrogen CNG as automotive fuel by the Ministry of Road Transport and Highways, NITI Aayog for their policy on advanced cell chemistry for the EV batteries, and various programs of biofuels by the Ministry of Petroleum and Natural Gas are just a few examples of government's continuously and collaborative efforts towards clean mobility and environment as a whole. CII is deeply engaged and working with all stakeholders on this important sector. CII, through its members and various state offices, have conducted many workshops to spread awareness about EVs and have conducted many webinars and conferences to bring all stakeholders to discuss issues and work out solutions for effective implementation of EV policies. CII efforts not only to strengthen the policy, but also to create demand and support to build a robust ecosystem by enhancing domestic manufacturing, strengthening battery and infrastructure development, and at the end, powering it with clean energy. Coming back to today's conference, the theme of today's conference is clean, connected, lean, electrified, alternate, and novel. Connected with cutting-edge technology and making commuting safer and convenient. Lean with mobility as a service has now given us a choice to how to travel. Electrified through plugging in to a charging point fueled by cleaner energy, alternative source of energy for energy security, and novel mobility or world-class mobility with modern amenities, convenience, and integrated public transport system. Over the next 2 days, we have scheduled 5 conference sessions, 3 on day 1 today, and then 2 are scheduled tomorrow. Today, the session includes connected mobility with the theme convenient and safer mobility. Our second session is alternate mobility with the theme energy security and low carbon fuels. And the third one is lean mobility with the theme mobility as a service. And tomorrow, the 2 sessions which are scheduled are electrified mobility with the theme electrification ecosystem and novel mobility with the theme cutting edge and integrated multimodal public transport. We'll put the proceedings of this conference together and share the key outcomes with all concerned, particularly the policymaking bodies. With these few words, I once again welcome all the participants for joining us today in the morning for this important conference. And we now begin with the first session of the conference, which is connected mobility. It is indeed an honor for me to welcome Mr. Dipanshu Sarma from Carvale.com, editor of Mobility Outlook, a soon-to-be launched media platform for the mobility sector, who is going to introduce the topic and moderate the discussion. I am equally honored in welcoming our distinguished panelist, Mr. Alexander Klotz from Continental Global, Mr. Dharmarajan from Hexagon, Mr. Tarun Agarwal from Maruti Suzuki, Mr. Raj Paul from Microsoft, and Dr. Kastgir from Warwick University, UK. Finally, I request the participants, if they have any question, please feel free to post it in the question and answer box, and would be there at the question and answer box would be there on your screen, and depending on the time availability, moderator will take those questions for discussion. I now request and invite Mr. Samra to take the proceedings forward and share perspective and moderate the session. Mr. Samra, over to you. Thank you very much.
Thank you, Mr. Khan. Greetings, everyone. At the outset, I would like to place on record my heartiest congratulations to the organizers of the second edition of the Future Mobility Show. As Mr. Khan mentioned, the first edition was a significant success, and building on it, the second edition promises to discuss a whole lot more. I also appreciate the invitation that has been extended to me to moderate this session, and I truly appreciate it. Thank you very much. So when we look at the next generation mobility, it will clearly be defined by safer, more sustainable, and convenient ways of moving around. And much of that will be enabled by connected technologies, one of the key global megatrends. Apart from adding significantly to the electric mobility shift and realizing the autonomous vehicle potential, connected technologies, when combined with big data, analytics, and cloud technology, also have created new business models, such as mobility as a service. The development of the connected car technology has accelerated digital disruption in the automotive industry. And some estimates put the market size to grow at a projected estimated to about $215 billion US by 2027, from a level of about 75 billion in 2019. Along with the rapid growth of the market's worth, there have been constant developments of new customer-centric services that go beyond driving experience. While the development of connected technology created a demand for connectivity solutions and driver assistance systems, companies willing to build their position in this market have to face some significant challenges as well. So in our discussion today, we will focus on how connected technologies have helped enable the transition we see in the industry today, and how they have helped in creating a more convenient and safe mobility. We shall also try and get an understanding on the various challenges the industry faces and what are some of the key opportunity areas. And to offer their perspectives on the subject, we are extremely honored and delighted to have an eminent panel of experts. Please join me in welcoming Mr. Alexander Klotz, Vice President R&D at Continental Global, Mr. Tarun Agarwal, Executive Vice President, Maruti Suzuki India Limited, Mr. Raj Paul, automotive industry leader for the America and India region at Microsoft. Dr. Siddharth Kastgir is the head of verification and validation for intelligent vehicles at the University of Warwick in the United Kingdom. Shortly, we will also be joined by Mr. Sridhar Dharmarajan. He's the Executive Vice President and Managing Director, India, at the Manufacturing Intelligence Division at Hexagon Software. Welcome, gentlemen. To begin proceedings, let us quickly go around this virtual table that we have today and get our first insights on the subject. And may I start with you, Mr. Klotz, your initial thoughts on the subject that we're discussing today?
Yeah, good morning, everyone. It's a pleasure to be here. I think you mentioned, out of the mentioned technologies and automotive trends, you just referred to automated driving, electrification, and connectivity. I think the connectivity is certainly the one that has a large potential, as you also referred to, and it's also something that the user would feel quite quickly the changes in. I think we will discuss during the panel a couple of technologies. Connectivity goes beyond the 4G, 5G. It's a connectivity also, to your smartphone with NFCs, with ultra wideband. It's a connectivity of IoT devices. It's that overall becoming part of the internet for the mobility experience, right? So from that side, I see a lot of opportunities in India. And we can discuss some of the challenges, but definitely that's on the fast track, I would say, compared to the other two, which have more dependencies even on the infrastructure side. So.
Thank you. I appreciate that. We will definitely come to discuss, the challenges and the opportunities later. Can I come to you, Mr. Agarwal? Your first thoughts on the subject around connected and convenient mobility.
I think in Indian context, when we look at things, connected will come easily and connected will come first, I feel. Because we already are connected. I think we are one of the biggest or second biggest users of smartphones, use of internet, use of data in India has grown many-fold in the last couple of years. But I think all those indicate that perhaps all users, at least of four-wheelers, maybe two-wheelers as well, are definitely connected in various ways. And bringing that to car will actually make their life easier, solve many of their problems. And I think convenience or convenient is an important word there. Along with that, perhaps we have our challenges of safety and environment. Some of those directly and indirectly can also be solved or partially solved by having connected technologies on board. My thinking is that in India's context, connected is very important. Autonomous or driver assistance is important, but perhaps our conditions are a little challenging. It will happen, but perhaps it will take a little longer than maybe other markets where it will happen first.
All right. Thank you. Thank you, Mr. Agarwal. Let me come to Raj. Your perspective, you are, of course, responsible for markets as mature as the US as well as India. So your initial thoughts on the subject today.
No, definitely. Thank you, Dipanshu. I appreciate the opportunity to be in this panel. So I think all of us would agree that, the automotive industry at large is going through disruption is what people use quite a bit, but I would look at it as a transformation. I think we're going through a phase where some of the basic modalities, how the industry has operated is getting questioned and transformed in a very nice way. And part of it, I'm sure all of us would have heard about CASE, right? Connected, Autonomous, Shared, and Electric. I was having a conversation with one of the customers, and they were saying, should it be CASE or should it be connected as more as a horizontal, because it's the foundational element for everything which this industry is going to expect from a transformation standpoint. Whether the new mobility scenarios which are happening, or from a safety standpoint, or I think some of the panelists touched on the context from a regional standpoint as well. Obviously India is going to be a lot different than the US, but on the flip side, I think India has been leading in a lot of ways. It's got a good number of mobile users. I think Mr. Agarwal touched on that. So I think connected and connectivity in the Indian context is going to be very important. And I think there is something people will take for granted, and the taking for granted is not just an Indian phenomenon, but more a global phenomenon. And we will see a lot of interesting offerings coming from OEMs, with the help of tier ones, like, for example, Continental here. So this transformation is a very healthy thing for the industry. So I think we'll have a good discussion today.
Thank you, Mr. Paul. I'll come to Dr. Kazgir, your initial thoughts on the subject. And at this stage, I'd also like to welcome Mr. Dharmarajan. Welcome, DS. Good to have you in the panel. We're just starting off. This is the first round, so I'll come to you right after Dr. Kazgir. Your initial thoughts, please.
Thank you, Dipanshu. Once again, just a big thank you and appreciate this opportunity to be on this panel. A couple of points that I would like to mention in addition to everything that the panelists have said. Fully agree with what has been said. One of the things that we are finding, and it's not only in the UK but also globally, is this transformation that was being mentioned is actually creating a huge opportunity from a regulatory and a governance perspective also. When you talk about new emerging technologies, and any technology for that perspective, trust from a user's endpoint is very important for it to be used and for us to see all these safety benefits that is a motivation for us. And in a lot of these cases, you would appreciate that we don't actually trust the technology, we actually trust the governance framework around the technology itself. So a classic example I would like to give here is, if you consider the vaccination program that we have, we as end users, we don't know what the vaccine is, but we have full trust in the governance framework that is governing the safety of those vaccines. So very similarly, when you talk about connectivity, when you talk about autonomy, when you talk about ADAS, it's the governance framework that we need to be proactive in building for us to be able to reap the benefits and get the public to trust these systems. So that's a few points over here. Very excited to see what the discussion and how the discussion unfolds on this one.
Excellent, brilliant thoughts to start with, Dr. Kazgir. DS, over to you. Your initial thoughts on the subject that we're discussing today. DS, you'll have to unmute yourself. You're on mute.
Yeah. Hi, can you hear me now, Dipanshu?
Yes, I can hear you.
Okay. Thank you for inviting me on this panel. My initial thoughts are, we are all aware that the maximum number of road accidents happen in India on a daily basis. We have the highest record of road accidents. And I strongly believe autonomous will drastically reduce those accidents, because when the machine detects an obstacle, it will immediately kind of stop. But how safe is the question, because we as humans accept accidents done by drunken driving or whatever much better than accidents being done by a machine. Because essentially, how safe is a concept. We can't tolerate a single death by a machine. So these are some of the emotional stuff that we have to overcome to really kind of understand. For us to really reduce the number of accidents, autonomous is the only way to go. Now, autonomy again is kind of from level 1 to level 5. We can decide what should be the progress, where exactly we should end up. Maybe government has mandated up to level ADAS. Maybe ADAS is roughly around 2.5, close to 3 level of autonomy, and that's been mandated by 2023, which we have to implement. But I would say that in a controlled environment like a golf courses or even in an airport, we can definitely go beyond level 3, maybe level 4 or level 5 autonomy as well. So we are in this whole phase of digital transformation, whether it is in vehicles or factories or mines or agriculture or whatever. And I think autonomous is definitely here to stay. And it's a question of when. It is not the question of whether we're going to do it or not, because that's good. That's really going to happen going forward. So I think I would say we need to have those technologies to empower an autonomous future across the all spectrum of industries that we operate.
Thank you, DS, for the initial thoughts. And now, are you experiencing any disturbance in the audio quality, or is it?
No, fine. Go ahead. No, fine.
Okay.
Go ahead.
Okay. Excellent. So when you look at several forecasts that are being done by 2023, the worldwide sales of connected cars is expected to exceed, let's say, 76 million units, right? And nearly 70% of worldwide new light-duty vehicles and trucks will be shipped with embedded connectivity, bringing new services and business models to the automotive sector. Now, in the Indian context, if I may ask Mr. Agarwal, could you give us a sense of the level of penetration that we have seen in the Indian market? You have said that of the global megatrends that we have, connectivity, connected technologies have taken a massive lead. But particularly in the let's say the lower B to the upper D segment, how do you see the penetration evolving, and what is the sort of growth you see?
So I think if you look at India, almost all major car makers have launched some kind of connected service or the other. Almost everybody. So some are giving as an aftermarket product, some are giving as OE products. Almost everybody has something there in the market. And as we have seen, any technology, typically it does take half a decade to a decade to become mainstream in India. So similarly, at least I very strongly feel that in another 2 to 3 years, we would see a majority of vehicles have connectivity built into them. Only thing is that our affordability in Indian market is a little different from other markets. Okay, I mean 60% of the vehicles we sell in India today would be somewhere less than maybe $6,000 to $7,000. Okay, so for those vehicles, it may take a little longer, but connectivity is definitely here, and I'm sure maybe by 24, 25 or something, we would have majority of the vehicles would have some connectivity or the other. Second point is, as somebody had mentioned, connectivity is not just having a telematics device built into the vehicle. It could be through the smartphone. That is anyway prevalent for last many years in India in most vehicles. So from that context also, today also, large number of vehicles are at least indirectly connected through a smartphone.
Fair point.
I definitely feel that connectivity has a big future in India. Also, the kind of data rates which are there in our country perhaps are most competitive compared to any other place in the world. That itself will drive connectivity in a large way in India.
For sure. I mean, you brought about an important aspect of affordability as well. Now, that is something that has always been one of the biggest, let's say, focus areas when it comes to the Indian industry, particularly with consumers. Mr. Claus, I'll come to you. I mean, Mr. Agarwal has given a thought around how he sees connectivity increasing in the Indian market, or the penetration increasing in the Indian market. Could you also give us a sense of your understanding, not just from a passenger car perspective, but also the other forms such as two-wheelers or even commercial vehicles?
Yeah, so before I go maybe answering that question, I want to touch on the point that was made before on the case part, right? What connectivity is to the case. Interesting thought there, because the connectivity is actually having a much broader impact than you might first think it has, right? I mean, maybe the navigation you would come across, or some streaming of music, whatever. But at the same time, I mean, with that connectivity, you're walking a whole different way. I mean, starting a journey into a different vehicle architecture where you have higher performance computing in the car that is enabling also over-the updates, for example, and using the car data to develop new functions or to improve functions. Something that is happening actually in the background and not so much prevalent to the end user. And for that one also, there's a huge benefit then certainly to have a connectivity built into the car that is also reliable and not depending on the user connecting the smartphone, yes or no, right? So I think what we are working on from Continental is then, I mean, basically, as I mentioned before, the connectivity from all the different angles. For the two-wheeler, for example, today you have Bluetooth connectivity to the cluster, right? And the really low cost bikes as well. You may not add a 4G module to it, but you have Bluetooth. You have some mirroring functions of important information into the cluster, because they are also getting some place meanwhile. So there you start really on what is most affordable. And then we go up to the high-end cars where we talk about this high performance computing, different sensors in the car, the sensors actually contributing to the intelligence of maybe a bigger road backend structure, and over the updates right? Providing the services to the car while it's already in use, right? Updating, upgrading functions, and certainly looking at cybersecurity, other aspects, right? So it's a whole bunch of, you open up a whole area of basically business opportunities as well. And what I also like was, I mean, the comments about highly automated driving, right? At the end of the day, when you think about safety, you cannot design connectivity to be always there, right? You cannot make a function of braking, for example, depending on a connectivity. But here again, right? What can I learn from the connectivity? How can my vehicle maybe update the maps? How can my vehicle contribute to swarm intelligence, warn other vehicles that are in the vicinity, right? I mean, there's an accident and every vehicle around gets an update via connectivity, even 5G vehicle to vehicle instead of going to the back end and coming back. So those kind of things are really quite manifold, right? So when you ask the question of connectivity, I always think much bigger than just the pure connectivity of 5G or even 4G. Yeah.
Right. Thank you, Mr. Claude. I'd also have a follow-up question to that. When we, you mentioned cybersecurity, of course, but that's something that we will try and address at a later stage. But what are some of the most critical security risks associated with connected vehicles, and what measures are being taken currently to address them? Could you give us a sense of that as well?
Yeah, I mean, it's a race that never stops, right? So we don't know. I mean, there's people hacking, and there's some people doing it for fun. There's some professionals, I mean, trying to earn money with it. So you never know what they actually want to do. But the worst case scenario you would be looking at, that somebody takes control of your asset, your car, right, and holds you ransom to get it back or to get control, whatever, like you see in the PCs, right? That is one of the big fear factors maybe out there. But we are now moving also, I mean, there's evolutionary steps, right? And on that way, we need to really prevent, understand, and also respond at any given time. So it starts with the design of the unit, of the embedded unit itself, right? What can we do to protect an individual ECU and like a engine control unit? How can we and secure now the communication between that unit and other units in the vehicle? And how can we secure the connectivity to outside the car? And that starts, I mean, vehicles, if you do a flashing, you can also do flashing of units today, right? So you need to avoid really that anybody gets an entry into that system, whether over the air, via Bluetooth, via NFC, via Wi-Fi, and also even via cable at the end of the day, to influence maybe other vehicles which are connected then. So it's an ongoing and a very broad activity we are looking at from the different business areas. So we're taking each individual unit needs to be secured, as I said, but we also have an overarching team. We actually acquired an Israeli company some years back, Argus, for cybersecurity, which are looking at the full operations of that, right? There's an incident in a car, there's an anomaly detected. How do you respond to that? How quickly can you react, provide a software update, and deploy it back over the air? So that's really a whole new business itself and a whole new ecosystem, including, as I mentioned before, the capabilities to update over the air, the capabilities to have lots of millions of cars monitored in the field, right, looking for anomalies and all that. We are not yet to that extreme scenario, right, because today there's still maybe some limitations in taking over a car or whatever, but we see those indicators, and we need to step by step really always be one step ahead of that critical hacking, right?
Sure. Fair point. I'd like to take that same question to Mr. Paul. Could you talk about the security aspect? Also give us a sense of the Microsoft's connected vehicle platform.
So definitely, I mean, I would agree with what Mr. Claude's highlighted. I mean, how security is looked at. I think you would have heard the phrase, the car is going to become another node on the network, right? So if you look at a lot of the practices traditionally, which we have seen in the enterprise, right? I mean, today your laptop is connected, right? It's connected to your network within the enterprise, but it's also connected to, I mean, you can literally compare a lot of things, right? I mean, the Bluetooth stack is there, right? I mean, I'm now connected using Bluetooth to the laptop. And the laptop also basically goes after information sources out there in the open, and then also goes after information sources inside an enterprise. And we have a pretty robust security today, I mean, to protect your laptop, right? I mean, now if you start looking from a comparison standpoint, from a car standpoint, there is so much of software getting into the car, right? It is connected to the internet. It is connected also to some dedicated trusted sources. And on top of that, now the user brings the phone and then it's connected. So you have a pretty complex system evolving within the car as well. So when it comes to security, I mean, the damage a hack can cause when a car gets hacked is a lot more than anything else which could be imagined, right? I mean, if an ECU gets hacked and if the car goes rogue, the destruction is, I mean, you can imagine the destruction that could create, right? So when it comes to security, I mean, you would have seen a lot of the hacks which was announced, I mean, over a period, I'm talking about the last decade, with different OEMs getting impacted. Some of them are actually very primitive things. You would think, how did they not think about this, right? I mean, I think that is part of evolving and people taking a step back to look at the car, just not on the node on the network, but a lot bigger than that. And I think from a security standpoint, one is how do you secure the sources which are going to give information to the vehicle so that, I mean, a rogue actor cannot get into the vehicle from an outside standpoint. But then inside the car itself, I mean, you know, I think Mr. Claude's highlighted, I mean, one of their acquisitions, they made Argus, and there are other companies in that space. There is a lot of work happening inside the vehicle so that you can protect the compute, which is actually increasing like day by day because of the need which the car needs now, and how you can secure that network inside the car itself. It's not just not the node on a much larger network, but it's actually the network in the car and what kind of checks and balances you can put inside the network as well. So from a Microsoft standpoint, I mean, obviously, I mean, as you all know that, I mean, Azure is our it's a flagship offering we have from a cloud standpoint. And of late, I mean, with 5G on the horizon, I mean, we are also looking at how to extend Azure into the carrier cloud so that you can essentially offer a lot of low latency applications which can leverage the cloud. So the whole integration of a carrier cloud to a traditional cloud provider like us and how the car basically plugs into that. So we are looking security from a holistic standpoint, end to end, from in-vehicle all the way to the cloud. And I mean, from an evolution standpoint, I think Mr. Clark put it in a very nice way, right? I mean, it's a race, right? You're going to have bad actors who are going to come in, and the faster you detect the bad actors and then stop them, I think it's better for everyone in the industry.
Excellent thoughts. DS, coming to you, and I stay with security for one more question. Do you feel there is still a lack of rigorous security testing, much of which takes place, let's say, too late in the product development cycle? Do you think that's still a concern? You're on mute, DS. You'll have to unmute yourself, please.
I keep unmuting, but somebody mutes me back. Okay. So what you're saying is so true. And see, there is only a limited testing that can be done. If you really look at it, just to compare, I just want to take a step back, compared to an automated car or a manual car. How does the human get a license to drive a car? He kind of goes through some training, and then he kind of goes through a particular test. The RTO does a test, and then he gets a license to drive. Similarly, an AI engine, how does it get access? How does it get a license to really drive the car, or the automated car, or a connected car, or whatever? So today, for him to do a physical testing, there is only X amount of kilometers or miles that he can drive. The car can drive to get physically tested. So I would say the only way to do it is to do more and more of simulation. Simulation is the only way to go. We need to ensure that we simulate the various scenarios, because today Google is able to simulate about close to 16 million miles a day. When physically you cannot even do that kind of physical testing. So simulation is a solution for all these things. So first of all, you need to capture the entire environment. So we have a product called Virtual Test Drive, and we also have this LiDAR cameras and the other things to capture the entire environment. And then you kind of simulate how the car should actually behave based on the various situations as well. And coming even to the security aspect of it, we can actually simulate the various kind of, we conduct so much of hackathon as well within the organization as well. So the simulation is the way to go. So I think testing, you don't have that much of time to test because there's so much of pressure to release the car on time to really reduce the product development time. So I would strongly advise that we have to do more and more simulation, whether it is simulating the way the car should behave based on the various environment, or simulating what it should behave to some external threat or something of that kind. So today we have a process, the hardware is there, software is there for us to do the simulation, and that should be the way to go. So you should be able to simulate the various scenarios, and at the end of the day, you have an AI engine behind the scene, which is kind of capturing the knowledge of the various simulations, so that even if the vehicle faces a situation which has not been simulated, the AI engine can actually predict what it should behave based on all the previous knowledge of simulation. The simulation is the way to go, is what I feel.
So, staying with the question around the subject of simulation, Mr. Agarwal and also Mr. Klotz, I mean, as a leading tier one player and a leading four-wheeler manufacturer, how important is this role that simulation can play in a connected world? Mr. Agarwal?
I think simulation is anyway important to us for decades now. For whatever we do, there is no way we can do everything physically. So whatever kind of design we do, whether it is mechanical design, whether it is electronic design, whatever we do, I think simulation is very, very important. In the connected thing, what is happening is, the way I look at it, I mean, earlier you sell a car and you forget about it. A car will live its own life, but you sell a mature product. Today you are selling a young product which keeps on maturing with time, even though customer is using it. And a lot of those updates and things are possible because you are parallelly doing a lot of development and testing and then pushing it to the customer. And a lot of that development, of course, will happen based on simulation of various kinds. So from our perspective, simulation is way to go. And of course, as an OEM, I can say that we depend heavily on tier ones like Continental and others. So we work in close collaboration with them to ensure that the aggregates are well developed. So any technology, you need to have multiple aggregates which you can use based on the requirements. So it is not about vehicle, it is ensuring that those aggregates are in place and then they can be used independently or in conjunction with other technologies as you go into a vehicle. And as somebody mentioned, Google's examples of so many million miles. So somewhere that kind of data, it is impossible to even think of doing everything physically.
Absolutely.
Okay. One of the challenges for India is, again, I mean, we need to have a lot of data for Indian roads and Indian conditions, which will be unique to us. And we need to develop and work out use cases which will meet those requirements. I mean, Google is not developing use cases where a tractor is coming in front of you from a wrong side, and you have to ensure that your whatever AI you put in does behave well in that situation as well. But in India, you can't have a vehicle doing something on its own on the road without taking care of those use cases or conditions.
Fair enough, Mr. Agarwal. Mr. Klotz, you had a point to make on that?
Yeah, so again, a slightly different perspective than if you look at testing, right? Not only limiting it to simulation, but the testing part. The connectivity, right? Also the penetration of the connectivity in India will heavily depend on the use cases that the OEMs and the manufacturer are able to show, right? I mean, this is something that the user really attracts and says, this is a major benefit compared to what I have maybe on my phone, or I just now have the phone attached to my helmet on the two-wheeler, right? So the embedded connectivity, is it giving me something? And so you also need to, when you talk testing, you need to also think user experience. And what is really the functions that are attractive? How do we attach how do we connect to the end user? And how do we improve your functions? And from that side, testing in a smartphone world, right, is actually happening in a much smarter way than we have been able to do that for hardware products in the past, right? I mean, you deploy the functions to some users, you try it out, you give an update, maybe only to 20% of the people before you launch it to everyone. You can have different versions. You can even use data analytics, maybe some user feedback to really understand what is the user really, what does he really need? Which functions are really attractive, instead of developing a big bunch of functions and deploy it and then find out nobody likes it, right? And I think that is an important part of the testing as well, because one thing we will not be able to simulate even in future, I'm sure, is what people really like, right? I mean, to predict what feature they will really for, and from that side, that whole user experience, which can be allowed to be monitored and to be tracked real time by connectivity, is a big top story to look at.
Excellent, thank you. DSI, for a company with a vision to empower an autonomous future, where businesses, industry, and humanity sort of sustainably thrive, right? That's how do you look at the developments in the Indian context, and what are some of the key areas that you think, if not passenger cars immediately, what are some of the other areas you think that connected technologies could come in?
Some of the areas that we are working on, in fact, if you really look at Hexagon, tagline is we empower an autonomous future. Whether it comes to manufacturing, or whether it comes to mining, or whether it comes to agriculture, or whether it comes to cities or whatever. So we are trying to make this whole thing smarter per se. So coming to the technology perspective today, I feel today that we have all the technologies available, all the advanced cameras are available in the Hexagon portfolio, where we can scan the complete environment to start to begin with. How do you start designing an autonomous car? First of all, we need to scan the total environment in which it has to operate. So some of the application of some of these cameras that we also do is in a security space where, for example, when the US president goes on a particular track, the whole track is scanned before he goes on the track. And once he starts going on the track, the scanning happens simultaneously. And the pictures are compared between the previous scan and the current scan. If there is any differences, immediately the security guy is alerted per se. So we have the hardware technology to capture the entire static environment, capture accurately the pedestrian. You could also simulate the various scenario capturing, as Dr. Agarwal talked about, a tractor coming in, or suddenly a cow coming in, or something of that nature, or how the car should actually respond. So even if you take the turning radius, if you want to take a sharp turn, when you're sitting in front of the wheel, you can decide what's the kind of pressure that you need to apply, and based on the turning radius, you can kind of turn the car. When you're not sitting there, you need to ensure that the car knows what's the kind of pressure to really apply on those wheels for it to really kind of turn the whole area. So you first scan this environment, you scan the pedestrian, you simulate the various scenario, how the behavior really happens, and start extrapolating and use your AI engine backend to start learning from this simulation. And if at all the car faces a situation which has not been simulated, AI engine should be able to predict what it should do. Now, all these knowledges we are able to capture in a hardware, and we can actually install in your existing car to make your existing car autonomous as well. So we operate in the complete cycle from scanning space. We have the hardware to scan the space, and we have the software to simulate the whole performance of the vehicle in this environment, and then manage this whole data, work on this data. Because what is autonomy is actually, as I said earlier, so cognitive automation is actually using the data the most effective way, because the data is generated in various areas. So we are today in the process of delivering about 60 autonomous cars a day to the various organization that is really required. So we kind of operate on an end-to-end environment, totally in the design space, manufacture space, keep the knowledge in the hardware, install the hardware in our existing car, we can make our existing car autonomous. So this is the direction that we are taking, either in automotive space or in mining space, because sometimes what happens is you have to work in the hazardous areas. In the hazard, you may not want to have a manpower mining in a very difficult area. So we have a complete autonomous truck design which can go ahead and mining and come back, and you can monitor the whole thing in a dashboard. And we're doing something like that even in agriculture, doing something like that in the various applications as well. So autonomy is definitely is here to stay, as I said earlier, and we create technologies to help the whole industries to be operate in an autonomous way.
So clearly you're developing solutions that are meant for the entire mobility segment across its various players. Dr. Dr. Kasgir, could you give us I mean, you raised a very important topic about governance framework, right? Could you give us a little more details on that? I mean, how do you think, or what are some of the global learnings that, let's say, a market like India could adopt?
Thanks for the question, Devanshu. Just building upon what was being said around using simulation and why we need simulation, because it's fairly difficult to do everything physically. But the challenge with the simulation also is, when do you know that you can stop? So how do you claim that how safe is safe enough? Because the amount of permutations and combinations, even in simulation, you will need to stop somewhere. And I think that's the place where governance frameworks and industry standards come and play a role, because that would guide you to say, if you've done these kind of things, that means we are confident enough that we can release the product. I think that's one of the key aspects over here. And to be able to set the bar fairly high is a very important aspect over here, because autonomy and connectivity, for it to be accepted by the public in general, needs to be trusted. And if the bar is not very high, then the first accident will lead to a complete loss of trust. So this concept of how safe is safe enough is where the governance framework and the industry standards can play a big role. And fortunately enough, this is something that the industry is coming together. So we're part of various international standards discussions, leading some of the standards, where actually the industry is working together to develop strong standards, because I think it's a fairly known fact now that no individual company on its own will be able to deploy a fully autonomous, fully connected, safe system. We need to collaborate across industry, and I think that's coming out very well now in the international discussions that I'm part of right now.
Thank you. Thank you. Could you also comment on the governance framework question that I had for you? What are some of the learnings that the Indian industry could adopt, keeping in context of today's discussion?
So one of the things that we've found in the UK and also in the European sector is the government and the various trade bodies need to take the industry stakeholders on this journey along with them. So the governments and the governance framework cannot work in isolation and say that this is what you need to do without consulting the different OEMs and the tier 1 suppliers. So I think it's about taking everybody, every stakeholder along this journey. And it's a part of it is also in ensuring that you also understand what is acceptable from an end user's perspective. So Mr. Klotz made this very important point that if you do not have the right use cases, then there's no point introducing the technology. Similarly, if you do not understand what would be acceptable from an end user's perspective in terms of privacy, in terms of safety, then there's no point building those kind of products. So even the governance framework, when you're talking about taking the industry players along this journey, there needs to be some way of capturing the general public mood around these technologies and the acceptable levels of safety and privacy. So in the UK, what we're doing is we're doing quite a few public engagement activities to understand and also educate the general public around the benefits and the challenges of this technology. Something similar, but would be useful in the Indian context. But I'm completely on board with Mr. Agarwal's point that we've got different kinds of challenges, but it's also an opportunity, because the larger the scale, the larger the benefit in that sense.
Yeah, I mean, staying with the discussion around, let's say, data policy and consumers' privacy, what is your view on that, Paul? Could you also talk about, let's say, the role that artificial intelligence will play in this whole connected technology domain?
Sure. I mean, two parts to your question. I mean, the first part from a privacy standpoint. The car is going to be a huge source of data, as we all know, right? And from a privacy standpoint, I mean, from a Microsoft standpoint, we think privacy is a basic human right. I mean, you would have seen us talk quite a bit about that. And I mean, our business model around how the customer's data gets used and everything. I mean, we have a very clear business model on how we treat that, and how we believe that it's an OEM's data and not Microsoft's data, and we're very clear on that regard. So when it comes to privacy, I mean, obviously from a US standpoint, there are a lot of regulations coming out. I mean, recently, California basically passed a law, and similarly in Europe, you have GDPR requirements. And I mean, I'm going to touch on governance as well. So I think there is going to be a governance framework on how a customer's data can be used and cannot be abused, basically, right? But and then also, if you look at it, there are a lot of learnings when we can take actually from the mobile industry as well, right? I mean, people, how they share their data and how data gets used. I mean, that is one end of the spectrum. But I mean, the car is always looked at as a conservative thing, is the way I look at it, right? So there's always going to be this balance on how do you treat privacy. But then more importantly, some of the customer-based scenarios, right? There could be a lot of interesting models where there's a lot of transparency on how an OEM could use the data, where customers should be given the opportunity to opt in and opt out on some of the services and what data gets captured and how the data will get presented to them. And I think that transparency will help as well to address some of the privacy concerns which gets raised in our industry specifically. I'm talking about. I'm not talking about the mobile industry at large. When it comes to AI, there are multiple ways you can look at AI, right? I mean, there is always the spectrum where people are telling, oh, AI is going to take over humankind and whatnot. I mean, I think there is a lot of benefits which I think AI is going to bring, right? I mean, let's take the car industry, right? I mean, I always look at this, the paradigm where initially having a CD player in the car was a luxury, right? I mean, I grew up in India. I know what we drove initially here and I mean, how that is involved, right? Then the CD player became a standard. Then a 2-line display was basically a big deal. And a nice fancy 7-inch or a 5-inch screen was only for the high-end cars. But if we fast forward now, pretty much the 7-inch screen is becoming a standard. But now how can we leverage that, right? I mean, now we're talking about, in order to avoid driver distraction, we want to use voice speech as much as possible, right? And now comes the next part of it, right? Can I use a digital assistant basically to be my companion when I'm driving, to basically deal with whatever I want and then bring in contextual information to me, what is relevant to me, so that I can bring down the driver workload as low as possible. And that obviously improves safer driving. And for me, that is going to be AI powered. What's wrong in that? Right? So that is just one use case. Then, I mean, obviously the common use case which people talk about is autonomous, right? I mean, autonomous, whether it's going to be L3 or L4, L5, doesn't matter. That is a lot of use of AI. I mean, that is how, I mean, I think one of the topics from an ADAS standpoint, right? I think that is, all these are great examples how AI has been put best to use in our industry. And I think that trend will continue because I think it is for the betterment of the industry and is the betterment for the passengers and the driver, more importantly. So I think our perspective there is, I think the technology has improved manyfold from an AI standpoint. And I think we got to be more responsible AI is the way I would put it. And I think most of the OEMs are approaching it that way, supported by the tier ones in that regard. And I think that trend will continue.
Mr. Klotz, your views on artificial intelligence, specifically in the 2 areas that we're talking about, building convenience in vehicles as well as ensuring its safety.
Yeah, so I think the touch points that the end user will have with AI, right? I think the most prominent ones was just mentioned, right? Maybe that companion part that can be on the display, that can be by speech, right? I think that's the most prominent touch point. I mean, looking at the data there, by the way, right? I mean, it's really interesting. The people are actually okay to give the data when they see the benefits, right? So will be also the question, what will be the benefits of data and using AI with that data in the car? And that is even broader than the speech, for example. So if you look at predictive maintenance, for example, if I'm giving away data from my car about the usage, about how I accelerate, how I brake, temperatures, whatever, and this helps me even further. I mean, sensor data out of a pump, out of an electric motor or whatever, that helps me to predict whether there's a maintenance issue or there's some potential failure coming up. Then why would I be worried, right? If somebody is reading out my motor data, right? Because again, it will help me not to be stranded on the road, right? It will bring my cost of ownership maybe down because early maintenance reduces then repair cost. And so we really have to look at different levels where we would apply AI. and what we do about it, right? I think really there's touch points to the user, as we said, the user experience that will be largely connected also to the ecosystem the user already have, right? It cannot be isolated that I go to the car and I have a complete separated ecosystem. It has to connect to my music streaming, to my calendar, to my normal life, if I will. And then there's things which are very car specific, and this one, for example, warning the user if he's maybe approaching a dangerous area, understanding the driving habits, right? Supporting him to drive safer, understanding, for example, he's driving for the first time, this car, this area, it's dark, all these kind of things you can really learn and be much more relevant to the user instead of just giving a regular warning, right? Or giving a regular manual that nobody reads, right? So how can I really support the driver? I think there are fantastic use cases which at the end of the day, the driver will also see the value of giving the data, and then AI can help to develop these. Yeah.
Mr. Agarwal, I'll come to you on a question. Mr. Klotz talked about the ecosystem, right? So connected technologies, not just for the vehicles, but also for the infrastructure, and how there is a sort of seamless integration between the two. And in that context, if you could also comment on the oncoming 5G technology, and what are some of the innovative solutions that possibly can be brought to consumers with 5G coming in?
I think before I go there, I had a couple of points on what people said. The way I look at data can be looked as individual data or collective data. A lot of things we talk about can be solved by collective data as a whole, not looking at a particular person's data. That's where the collective data can benefit the community as a whole. It may not be just the individual. So if collective data can solve problems of congestion, and the allied problems of pollution, we can give some better guidance to the community as a whole. I'm sure there could be many use cases where collective data can help us. Also, in connected space, to solve problems, you have to be truly connected. So are we able to collaborate with government agencies, people who provide emergency medical care? So unless you have those connections, you will not be able to make true benefit out of the data. And I think that's one of the challenges I see in India today. Also, as a car maker, can I improve my vehicle? Can I give features which the customer really wants based on his usage? Traditionally, I would get customer information based on a CRM call or maybe once a 6-month visit to the service center. But today that is changing. I'm in touch with the customer every day, and based on that, I learn a lot more about it, how the vehicle is actually getting used. So for example, somebody mentioned about breakdown. All of us must have one fine day realized on a winter morning that the car is not starting. The battery has gone bad. So can I tell him a week or 15 days in advance that it is good time to change your battery? Otherwise you'll get stuck. So those kind of benefits can be based on the individual data to the driver himself. Coming to 5G, I think latency is the key. So tomorrow, once the latency is taken out of the system, you can think of many more use cases. Okay, and if really we can give warning to the customer in Indian context based on low latency of 5G, that definitely can reduce or save some lives in Indian context. And I feel in India, safety could be the first thing where we can use technology, perhaps. That's the biggest challenge for mobility to grow as well. For us to reach the levels of mobility or levels of car ownership, which is there in the Western world, we have to ensure that our roads are safer. We can't go to from 20, 30 per 1,000 cars to maybe 500 cars with this kind of safety record what we have today.
Yeah, that's an absolutely important point that you raised, Mr. Agarwal. Can't agree more with you on that. DS, coming to you on the same subject of 5G and then how 5G can actually enable autonomous driving. So could you comment on that, please?
5G essentially means connectivity, either over the air or long distances or arbitrary locations, high speed, lots of data. maybe as somebody even very rightly put it, context, can we get a contextual information? So, but I would say that the ability to communicate is just not enough, okay? We need to ensure that the information that, that you receive has to be understood and interpreted in the right way, okay? So 5G, I would say, accelerates this whole process of the autonomy. The reason being, see, while you might have done a lot of simulations, as I said earlier, you also talked about how AI would help. But I would say for us, we use AI engine effectively to ensure that it learns from the various simulation that it has actually done. And if at all it is facing a situation it has not faced before in the simulation world, can it really act based on the knowledge that has really kind of captured? So 5G really kind of helps. And of course, I really like what Siddharth spoke about, all these under the government framework and all these within the laws that really kind of operates. So today, so essentially, even when the autonomous car is going, we have the cameras constantly capturing the various situations. And sometimes the simulation is actually happening real time. So we need to know that the vehicle dynamics happens real time, and the prediction, how the car should behave at various moments. So the simulation is not done in the earlier situation. Simulator must have done offline, and then you kind of come back and implement the results. In the autonomous world, the simulation is being done as the car is actually being driven. And 5G is really kind of accelerates this whole process and ensure that the simulations are done faster, the predictions are done faster. For various scenarios, the outcome, that the response of the car should actually be as close, or if not better, like what a manual driver would actually behave in that particular situation. So you have all these parameters like, your the emergency braking situation, all this situation, we have Volvo has done a pretty good job in implementing some of these things as well. And I would say 5G will only help us to adopt autonomy at a much faster pace than what it is today.
Right. Paul, coming to you, if you could talk about India's readiness with regards to ADAS, for instance. Mr. Agarwal did make a point earlier about safety, about the possibility of actually getting ADAS into the Indian scenario. What do you think could be India's roadmap when it comes to adopting ADAS for the Indian market? Mr. Paul, can you hear me?
Yeah, I'm between. I just broke a little bit. My internet connection getting a little bit flaky. I'm sorry. So,
all right. Did you get my question?
Yeah, I did get your question. Yeah.
All right. Okay, fine. Yeah.
So from a 5G standpoint, I think the low latency, as we all know, is going to basically be the killer app, right? I mean, there are a lot of different things you can look at. From an Indian context standpoint, I think the ADAS adoption when it comes to safety security will start basically playing a much bigger role than some of the higher end ADAS functions. So in that regard, a lot of the V2X functionality can be enabled easily when 5G starts getting rolled out. So in that regard, I mean, some of the infrastructure which is required today to do V2X, I mean, V2V particularly, and I mean, from a safety standpoint, if you look at it, I think 5G could light up a lot of those use cases. And I think a country like India, or I mean, a country like US, doesn't matter. In that regard, I think some of those use cases will get lit up very fast. DSRC has been talked about for a very long time. Some OEMs adopted it, and then if you look at it, it's still getting talked about. But I think in that regard, with some of the C2V2X scenarios, when OEMs do connect all the vehicles and cellular is going to be a connectivity taken for granted, I think that's when you'll start seeing a lot of the use cases when it comes to V2X come to life. And I think that'll play a big role when it comes to safety security.
Fair enough. Mr. Klotz, coming to you on the question of ADAS, India's preparedness, and the possibility of actually offering the whole gamut of solutions that's available from vehicle to vehicle to vehicle to infrastructure, or like Mr. Paul said, V2X, communication with anything. What's your perspective? What's your view? Where do you think we are? And what are some of the immediate solutions that India could actually adopt?
Yeah, very wide answer I could give. Let me try to focus a bit. So one topic when you talk ADAS, I think we have certainly to understand that the Indian road conditions and the context of driving is very different from many other countries. I mean, taking the typical interstate scenario, driving for 3 hours without even, touching the brakes or the accelerator was the norm 20 years ago in the US, right? And so you had just a cruise control, you put it on and you just control the steering. And now in India, this is not the typical scenario for most of us, right? We have then the city context of Bangalore, we have bad roads, we have bad lighting, and maybe even missing connectivity in some parts. So certainly the question then is, what's the most attractive function then for the Indian context? And I see there certainly that the topics navigating in tight environments, right, is a quite prominent one. So that brings the idea of, for example, surround view, or how to really in a lower speed scenarios, how can I make sure the driver's understanding the blind spot, is understanding maybe there's obstacles on the road or next to me, somebody's approaching me from behind. We've introduced a system in the market, which is the transparent hood, right? So where you basically on the screen, you would see what's underneath your car, right? Because there's maybe potholes, stones, whatever. Those kind of things, navigating in a tight environment, in small alleys, certainly is something we see as a interesting use case that also drivers will understand right away and use maybe quite daily. And then certainly you can look into supporting the driver, in like the ACC functionality, right? Where you can really help him to keep the distance, and emergency braking, which is even debated for and is an aim for legislation then, right? Making sure if the driver is distracted for a moment, that the vehicle is braking automatically, if you will. So from that side, these are some, let's say, low-hanging fruits, I would say. And then we have to continue and work, with like companies like Maruti Suzuki, with the customers, and see, what is really the most interesting use case, because we are in a value-driven market, right? And buying a car then that allows ACC function, so the adaptive cruise control, in high-speed scenarios, maybe the user will not be willing to pay a lot of extra. And we just heard again a bit earlier that the typical sales price in India is quite low, and then even affording those sensors is a challenge, right? So I think we really have to be close to the end user and make we will create the appetite with these functions, I'm sure. Once you have them, you don't want to miss them anymore. And you're even asking for more, right? Higher speeds, more use cases. So I think that will be the road. To some extent, only evolutionary will be possible.
Fair enough. Dr. Kazgir, I'll come to you. A question on, if you could give us a sense of some of the new areas you think that are being sort of experimented, researched, as far as building in more convenience is concerned to vehicles overall, not just for passenger cars, but across the spectrum. Could you talk about that, please?
That's an interesting one, because I was actually, while we were talking about connectivity, that's exactly what I was thinking. Because whenever we talk about connectivity, we tend to very quickly narrow down on the benefits in autonomy. But there's a lot of benefits from connectivity in energy efficiency also. And that's something that we need to bring into the Indian context, and because it's a kind of a low-hanging fruit. So technologies like green light, optimal speed advisory, intelligent speed adaptation, those are not autonomous features, but they are very much there to help you from an energy efficiency perspective. So this move towards electrification, a lot of connected solution could actually enhance the benefits that we'll get from electrification in the Indian context. I think that's an area where we're not focusing enough, and I do see quite a few benefits coming out of if we merge the electrification agenda with the connectivity agenda. Because I think anyways we're focusing on connectivity, but if we bring the two together, the benefits would be quite enormous, I would say. Well, another point I wanted to mention around the fact that the use of AI, the point that was made earlier, and there's a lot of emphasis around AI in general, but we tend to distinguish AI into two types of AI. One is AI for recommendations, so all the assistance features, the companion features that Mr. Paul was saying, and the other one is when AI is actually making the decision on your behalf. Now that is a completely different ball game when it comes to higher levels of automation. And that's a challenge that we are trying to address both as a research community and also as an industry, as to how do you claim a safe AI when the AI system is responsible for your life? That is a different question.
And that sure is a very interesting question. Anyone in our panel who would like to take that up as well?
I can add my favor to that. So, I mean, as I said, responsible AI. So, I mean, I think we talked about ADAS, and I think we all agree that our ADAS function, which is going to basically help the driver. Right? So, in that regard, if you look at it, there are decisions which sometimes the driver may not be fast enough to do. I mean, a good example, I think, one of the examples when I did a little bit of research from an Indian context standpoint, right? India is a pretty complex environment when it comes to city driving. Right? But then if you look at the number of accidents and what the driver can't see and what the machine, in this case, the car can see, is a lot different. So in order to capitalize on that, I mean, AI is going to play a very big role. I mean, for me, if I know there's a car coming in the next intersection, which I visually am not seeing, but the car sensor sees, or, a good example, I think I can actually use a real example. A few days back, one of my colleagues was driving back to Chennai after visiting his parents out of town, and looks like it's a freeway, and all of a sudden an animal shows up in the front because the road median was broken or whatnot, and I think he hit the animal. And he was so lucky that other than damage to the car, nothing else happened. That's a real case which is evident in a lot of places. And I mean, I'm sure an ADAS function, if the car had it, he could have avoided that. And some of those ADAS functions has to leverage some of the AI techniques we talked about. Mr. Sridhar talked about, some of the simulation which we have to do and whatnot, right? If you look at the levels of automation, I mean, when you talk about the higher levels of automation, when the human, the autonomous driver is going to take the place of a human driver, a lot of the testing happening with a lot of the OEMs where the human safety driver doesn't exist because there's no steering column anymore. The only way you're going to do that with this simulation. And if you look at the amount of data which is going to come out, AI is going to play a very big role in that, right? So I would actually say that it's going to be responsible AI. With regards to delegating the decision making to a machine, right? I mean, today there are levels of autonomy which is coming out, like, for example, Tesla, GM with Super Cruise, Ultra Cruise, and whatnot, where it's going to be a man-machine marriage, right? I mean, the human is still involved, right? Of course, when it comes to L5, that is going to change, right? So I think as long as we use AI in a responsible way, I think it'll bring in a lot of value to the driver from a safety standpoint.
One comment here on that, also to differentiate two things. One would be, do we have that car, that individual car that is learning for itself and it's driving that road and then it's adapting on the fly, doing something nobody predicted. With this, we use the cars, right? And we use the data to generate, and the help of AI basically to improve the functions, but they are still tested and verified in an offline way before they are deployed to multiple cars, right? So that the car is basically really learning on its own and your car is behaving different from another one. I don't see that happening, right? So we will still have to really learn from that and still make sure that we have processes and checkpoints to make sure before we let that AI function that was
I just wanted to add, Mr. Paul put it so beautifully, the marriage between the man and the AI. Because ultimately, this is a journey that we are in, and level 1 to level 5 autonomy is a journey that we are in. And I would say that a man alone or an AI alone today is not as good as a man plus AI working together. Over a period of time, as and when the AI keeps learning more and more and more, and as we move to the level 5 autonomy, automatically the AI will become the truly responsible AI. So I think it's a journey that we are in. So I would say a man plus AI today definitely works much better than a standalone man or a standalone AI.
Excellent. I will have one more question for the panelists, and after that, I'll try and take a couple of questions from our attendees. At this point, I would also like to request all of you attending this panel discussion, if you do have any questions for our panelists, please do not forget to send them across using the chat window that you have on your screens. So my final question to the panel today is, I mean, all of you have talked about the importance of collaboration, right? Mr. Paul, you would have several examples to talk about, especially when it comes to, let's say, the connected environment that Microsoft is building, of working with partners. And similarly, Mr. Klotz, you spoke about collaborations as well. So overall, if you could all give me a sense of the importance that you think, especially from on this domain of connected technologies that we're discussing today, how important is collaboration and what are some of the developments we could expect? Mr. Kazgir, maybe Dr. Kazgir, I'll start off with you.
Okay, I think there are two aspects I look at collaboration over here. One is the collaboration on the technology development side itself. And in the UK and in European context, I've seen a lot of that happening with various government-funded projects where different stakeholders from different countries coming together, working on this common mission of trying to create a safe, connected, and autonomous system. The other side is where I see, again, from first-hand experience, is the collaboration in creating these standards at a national and international level. So I personally am part of various ISO committees, leading a couple of the international standards, and it's very heartening to see that different tier 1 suppliers and manufacturers are at this, while protective of their own interests, but also protective of the wider societal benefits that we are getting. So whenever there is a discussion around should something be done in a particular manner, the first question every manufacturer and tier 1 supplier asks, is that safe or not? And I think that is something that is key over here, that everybody is motivated by the same societal benefit. But yes, being a commercial organizations, everybody will have to protect their commercial interests, but it's the safety that underpins everything. So I think it's a two parts of collaboration on the technology development and on the standardization front, which also need to inform each other. You cannot develop a standard without knowing what the technological requirements need to be. So I think these two aspects would go together, and there are lots of good examples across the world in both sectors, I would say.
Mr. Agarwal, your comments?
I think to get the true benefit out of these technologies, collaboration is a must. And collaboration will happen at various levels. To some extent, various OEMs also would need to collaborate to be able to use data effectively. Similarly, collaboration would be required with government agencies as well.
Right.
Also, I mean, for example, today, government has mandated a certain kind of telematics devices to be fitted in all taxis in India or all commercial vehicles. But perhaps all that data today is in silos. But if that kind of data is available, a lot of policy making, a lot of good decisions can be taken to improve the safety. So in Indian context, it is important that we have some kind of standardization and ability to use data while ensuring that the worry typically is that whether my own IP or business interests are protected while sharing. So I think having that right balance between the two is important. But going ahead, a lot of problems can be solved if we are collaborating with others. It will be very difficult for any individual organization within the state side or the industry side to solve problems only by themselves.
Themselves. Okay. All right, Mr. Paul, your observations.
So from an automotive industry standpoint, I mean, the traditional model where tier 1 produced a part, the OEM built a car and the dealership sold the car is fundamentally getting redefined, right? So now if you look at it, I mean, the example I always use is, let's fast forward later on. I mean, it's starting to happen now. I'm just using a future example. If an autonomous car gets into a city, right? I mean, it just can't keep driving around. Let's check it's in ride hailing mode, doesn't have any passengers, it just cannot keep driving around, right? It's got to figure out where to go and pull over and charge, right? Which means you're going to get now an interaction with the charging network provider. Next is probably it has to basically go and park because the city ordinance is that there's only so many cars which can be on the road. Now it's got to deal with the city. So our industry is now, I mean, I think Mr. Agarwal touched on some of the other use cases when it comes to data sharing and whatnot. I think our industry, I mean, I think you would have heard the mobility service provider concept, right? Where a lot of OEMs are now trying to basically become a mobility service provider themselves. And there are new entrants which are purely focusing on being a mobility service provider as well. I think it's a nice time where the industry now is becoming more horizontal, where a lot of industries are going to participate in the automotive industry in general, whether it's going to be a public sector or a telecommunication industry or a basic infrastructure provider participating. I think this is going to be a collaboration play. It is not a winner takes it all where one person does it and then tries to reap the reward. And I think the model will be where it is a full collaboration and a partnership play.
Yes, Mr. Claude.
Yeah, so I mean, I think Mr. Agarwal would be able to speak more about it, but I think the automotive to build a car was always driven by a lot of collaboration, right, and integration. And same on the tier 1 level. I mean, one of the most complex products you actually encounter in your life is a car, right? With a lot of electronics, software in it, and I mean, we see these high performance computing now going into the cars with, I mean, 20 million lines of codes. Is the high performance computing we launched recently with one OEM. So that's quite a collaboration you have there already. But the interesting part is more the what is the change there really? I mean, in the past, as an OEM, your main role was to develop a car, test it, and deploy it to the market in a safe way. You never touch it again, basically, right? It needs to work anytime, anywhere. I mean, in the desert, in the cold. And the driver is actually, I mean, really depending on that. And even after 2 weeks, 3 weeks, 6 weeks, whatever, you come back, the car has to start, right? And now we are coming into a lot of dependencies, right? Now you design functions which need connectivity and they don't work if connectivity is there. What's even the user acceptance to that? Now there's a feature not fully ready when the car is, when you buy it, it will only evolve over time, right? So how about these updates and all that? So there's a lot of things which are really changing. We touched on the point also that Mr. Paul said it, that the providers and the players are changing. What was a tier 1 before becomes also a tier 0.5. You have vendors that are providing chipsets. They are stepping up into functions. You have the service providers. There's a lot of more collaboration needed actually to make a mobility ecosystem work. And so from that side, I think we are even in forums like that just show we are into that, we are open for it, we are doing it, because we all are convinced that we need it, and without collaboration, we're not able to provide the features and innovations to the market.
Absolutely, absolutely. TS, your final comments on this?
See, collaboration is a must. I know we've already seen it happening. For example, in Europe, there was this group called Pegasus. Pegasus really stands for Project for Establishment of Generally Accepted Criteria, Tools and Methods, as well as scenarios and situations for the release of highly autonomous cars. So we have to have standards, because if at the end of the day, if one OEM is designing his car in one particular way, the other OEM is designing the car in a particular way, how do those two cars get along in the same road? So these are some of the standards this group has established. There is another group called S3 Enabled, which is also working beyond the automotive industry as well. So these groups, they have been proactive to set the standards of how one should design their autonomous cars. And as rightly Paul spoke about, the whole disruption is happening the way the cars are being developed. And even Mr. Coles talked about how, he very interestingly put it, how Tier 1 is becoming Tier 0.5, almost pretty close to the OEM kind of an environment. And the more we collaborate, the more we can create a safer environment, a safer car on the road. So collaboration is a must. There's no doubt about it. Not only OEM, Tier 1, the OEM plus the suppliers, plus the government bodies, plus the regulatory bodies, all of them need to collaborate to ensure that we have the same set of standards that all of us operate to design autonomous cars.
So clearly there is absolutely no doubt. There's absolutely no doubt the benefits that collaboration can bring in, particularly keeping the future in mind. We have about 4 minutes to go, and I have 2 questions from our attendees. The first one is about autonomous driving on Indian roads is a big challenge. How is the ADAS being optimized, adopted, and validated to the Indian roads and environment. Dear Dear, you're muted.
Sorry.
Yeah.
Okay. So what I wanted to say is India is definitely on the path to adopt ADAS system. We heard the Mr. Gadkari talking about to be mandated by 2023. Some of these things like your automated emergency braking or adaptive cruise control or lane keep assistance. These are the things that are definitely going to happen. These strategies, the connected mobility will have to play a key role. And for these accurate and cheaper ways, I may be sounding repetitive, but we need to definitely do more and more simulations and create a safer environment to happen. So this is a question of it is not a question of whether it will happen or not. This has to happen, and I fully agree that Indian conditions may be much more tougher than any other conditions in the world. But that's the reason why even Gadkari was speaking about where he will never allow a completely driverless car. So essentially, he will never allow level 5 autonomy. But I would say level 2.5 or 3 is definitely going to happen. And that is going to reduce the accidents that we're having. We are one of the highest accidents per day in the country. And I would say ADAS would actually help us to reduce the number of accidents per day on the Indian roads. So I think the technology is available today. There are people available today. The OEMs, the entire ecosystem is working very hard to ensure to make it happen. And by 2023, this is already being mandated. I just hope it doesn't. Some of these regulations they keep changing the date. But I think we are definitely on the target, and we should have this happening by 2023. The ADAS functionality on the Indian roads for sure.
Thank you. Thank you. I'll take the final question that we have today. One of our attendees wants to know how much is the significance of poison testing, which deliberately plants adverse driving conditions to simulate Indian driving conditions. Who would like to take that? Can I take that to Mr. Agarwal?
Sorry, I couldn't understand the question correctly.
Okay, I'm going to repeat it. He wants to know how much is the significance of poison testing, which deliberately plants adverse driving conditions to simulate Indian driving conditions. Or anyone else, Dr. Khatsgir, do you want to
I don't know what he means by poison testing, but whatever testing we do, our endeavor always is to simulate Indian conditions. I may not like the way somebody drives, but ultimately I'm selling a product to him and I have to ensure that meet his or her expectations. So in a company like ours, for example, one of the things which Connected does is to give us data how people are driving. And we keep on improving the way we test vehicles based on the data we get on the actual usage of the customers. And also, I mean, despite our not wanting, we do get market feedback. I think all companies do. Right? That makes us learn every time and then evolve new methods of evaluating vehicles before we ship them to the customers.
So thank you. We are at 12:45 sharp, and I would like to close this discussion here. Thank you so much, gentlemen, for being such a wonderful panel, discussing diverse subjects and bringing to the fore interesting insights on connected technology, both for the safer and convenient future. Thank you once again. I truly appreciate your participation. Thank you.
Thank you.
Over to you, Mr. Khan.
Thank you.
Thank you.